Hello, everyone. In this session, we are going to understand the introduction of plant and maintenance, along with its use cases. We will also walk through the process flowchart for better understanding. So, let us start by introducing plant and maintenance in the Onfinity system. Plant and maintenance is the process of keeping machinery and equipment in good working condition to ensure optimal performance, longevity, and reliability of the equipment. It involves various types of activities. They are preventive maintenance, which includes regular checks to avoid potential problems, breakdown repairs, which involve fixing equipment when it is unexpectedly down, corrective maintenance, which involves resolving minor issues before they become serious, routine inspection, to ensure everything is working as it should, and predictive maintenance. These tasks help to reduce downtime and improve efficiency to save costs. To manage all of this efficiently, we use the Onfinity system. An organization uses a maintenance module that helps in scheduling tasks, tracking and documenting maintenance works in an organized way. This also ensures that safety and regulations are followed at all times. We will understand this by using a use case named breakdown maintenance of an industrial air compressor. A business user reported a problem with one air compressor. The issue was that the pressure was inconsistent. Sometimes it was too high and sometimes it was too low. After the complaint was registered, the maintenance department received a notification. They sent a technician to the site to inspect and fix the problem. When the technician arrived, he found that a new air intake filter needed to be installed. He installed the filter. During his inspection, the technician realized that he needed to add another follow-up task to fix the issue properly. However, he could not install it immediately at that time. So, the technician created a follow-up task for the new valve installation and assigned it to another technician. The second technician accepted the task using the mobile application and reached the location the next hour. He completed the follow-up task, which included the installation of a new pressure control valve spare part. After that, the technician confirmed the request, and the supervisor completed the request. In the Onfinity system, users can perform all these steps by using the mobile application. This includes reporting issues via a phone call, creating and accepting tasks, updating progress, and closing a request. We will understand this in later videos. Moving on to the process flow, there are three types of flows in plant and maintenance. They are reactive maintenance, direct preventive maintenance, and auto work creation. We can understand each of these one by one. So let us first understand the reactive maintenance process flow by creating a service request. Let me open the flowchart in PDF format in the browser by using this link. This is the reactive plant maintenance process flow by creating a service request. This process flow is divided into four parts: the plant admin, the field technician, and the warehouse manager. The process starts with the plant administration. The plant admin will receive the request. After receiving the request, the plant admin creates a service request in the system by entering relevant details such as the maintenance type, asset details, required service type, and a description of the problem. The user can then enter the target update and time, which is the date and time when the service issue is expected to be resolved. Once this is done, the plant admin completes the service request, and the system sends a notification to the maintenance team for the creation of a work order. The plant admin will create a maintenance work order with the reference of the service request. Based on the service request, the system automatically updates the details on the maintenance work order screen. Then the user can add the task, and the add task process is running. Once the add task process has run successfully, the task along with its associated spare parts, maintenance tools, and checklist will be auto-populated. This is based on the task group configuration that was already covered in the task group master setup session. Alternatively, the user can add the task manually in the work order screen by creating a new record and then adding the checklist, maintenance tools, and spare parts manually by creating a new record. After that, the plant admin will assign the task to the technician and create a task schedule according to the technician's availability. Once the task is assigned to the technician will receive a notification on their mobile application. On the other hand, the resource can also create their own schedules according to their availability. This can be done by using the mobile application. Once the task is scheduled, the technician will check the availability of the required spare parts in their warehouse. If the spare parts are not available, the technician will raise a request to the warehouse manager for issuing the required spare part quantities. The warehouse manager will then issue the spare parts to the technician by using the inventory use screen. After that, the technician will perform the task by using the mobile application. All of the related fields on the maintenance work order will be automatically updated in the Onfinity system. While performing the task, the technician will also fill out the checklists and upload associated images. These images will be automatically saved into the DMS in the Onfinity system. When the task is completed, the technician will update the work order status through the mobile application from assigned to complete. After that, the plant admin will complete the maintenance work order. This is the entire process flow for reactive plant maintenance in the Onfinity system that we have covered. We'll now understand the next process flow, which is direct preventive plant maintenance, by creating a maintenance work schedule. I'll open this link to navigate the process flow in a PDF format. This is the process flow of preventive maintenance by creating a maintenance work schedule. This process flow is also divided into 4 parts: the plant admin, the field technician, the technician, and the warehouse manager. The flow starts with the plant admin. The plant admin creates a maintenance work schedule by entering relevant details, including the maintenance strategy, which defines the intervals at which maintenance orders will be generated. After creating the maintenance work schedule, the user can add the task by running the add task process. Once the add task process has run successfully, the task along with its associated spare parts, maintenance tools, and checklists is auto-fetched. This is based on the task group configuration session that we already covered in the task group master setup session. Alternatively, the user can add the task manually by clicking on a new record and adding checklists, maintenance tools, and spare parts manually in the system. The user can then enter the planned work order date. This basically refers to the date on which the work order needs to be generated. After entering the relevant details, the plant admin will complete the maintenance work schedule. Once the maintenance work schedule is completed, the system will send a notification to the plant admin for work order creation. The plant admin will create the work order based on the planned date, with the reference of the maintenance work schedule. Once the reference of the maintenance work schedule is entered, the system will automatically update the relevant details on the work order screen. Then, the plant admin will assign the task to a technician and create a schedule based on the technician's availability. Once the task is assigned to the technician will receive a notification on their mobile application to perform the task. On the other hand, the technician can create their own task schedule based on their availability. Once the task is scheduled, the technician will check the availability of the required spare parts in their warehouse. If the spare parts are not available, the technician will raise a request to the warehouse manager for issuing the inventory of spare parts. The warehouse manager will then issue the inventory of spare parts to the technician using the inventory use screen. After that, the technician will perform the task. After performing the task, the system automatically updates the relevant details on the work order screen in the Onfinity system. While performing the task, the technician will fill the checklists and upload any images against the checklists. These images will be automatically saved into the DMS in the Onfinity system. When the task is completed, the technician will update the work order status from assigned to complete. Once the task is completed, the technician will notify the plant admin to complete the maintenance work order. The plant admin will complete the maintenance work order. So, this is the entire process flow of direct preventive maintenance that we can understand. In the direct preventive process flow, we create the maintenance work schedule first. And in the case of reactive maintenance, we create the service request first. Now we are moving to the third process flow of preventive maintenance, which is the auto work order generation process flow. Let me click this link to open the process flow in a PDF format on the browser. Now, let us understand preventive maintenance by creating a maintenance work schedule through the auto work order generation process. This process flow is divided into 4 parts: the plant admin, the field technician, the technician, and the warehouse manager. This process will start with the plant admin. The plant admin will receive the request and create a maintenance work schedule by adding the task, and the add task process will run. Once the add task process runs successfully, the system will automatically update the task and the associated checklists, spare parts, and maintenance tools based on the task group configuration that was already covered in the task group master configuration session. Alternatively, the user can create the task manually by clicking on the New Record button on the Task Details tab of the Maintenance Work Order screen and add checklists, maintenance tools, and spare parts manually in the Onfinity system by clicking on the New Record button. The user enters the planned work order date, which refers to the date on which the work order is generated. The plant admin will then complete the maintenance work schedule after entering all the relevant details. After the completion of the maintenance work order schedule, the plant admin sets the auto work generation process with the reference of the maintenance work schedule by navigating to the auto work scheduling screen in the Onfinity system. The system will then generate a work order automatically based on the planned work order date and the maintenance strategy. After the generation of the maintenance work order, the system will send a notification to the plant admin. The plant admin will verify the created work order details. After that, the plant admin will assign the task to a technician and create a task schedule based on the technician's availability to perform the task. Once the task is assigned to the technician will receive a notification on their mobile application about the task details. Otherwise, the technician can schedule their own tasks by using the mobile application. Now, the technician will check the availability of the required spare parts in their warehouse. If the spare parts are not available, the technician will raise a request to the warehouse manager for issuing the spare parts inventory. The warehouse manager will then issue the spare parts to the technician using the inventory use screen. After that, the technician will perform the task by using the mobile application, and the related fields on the maintenance work order screen will automatically update the data. While performing the task, the technician will also fill the checklists and upload any associated images. These images will be automatically saved into the DMS within the Onfinity system. When the task is completed, the technician will update the work order status from assigned to complete and notify the plant admin about the work order completion. After that, the plant admin will complete the maintenance work order. So this is the entire process of preventive maintenance through auto work order generation in the Onfinity system. Thank you for attending.